first things first, I'm going to open up Automation Manager, my own machine, there we go, and start with a new blank policy. And let's call this one conditionals and lens. Okay. So Automation Manager has all of these blocks of objects over here on the left-hand panel. And we can look at some of the more common ones that you're going to use as part of your policies. And what I would suggest is go ahead and add them to your favorites if they're ones that you do frequently use. So I use the if else and the log statement most often, so I will go ahead and add them into my favorites up there as well. So on the left-hand side, you will see very handy here, the conditionals objects. So you remember from yesterday, the if then and if else conditionals that we used. And that's probably, at least for me, that's going to be the number one most common object that I use. Testing for a condition and then branching on the outcome. So if yes, this, if no, that. It's actually a fundamental part of any computer architecture or programming language, so much so that having those conditions is required for being, what is so-called Turing complete. And with that, no, control flow. Sorry, not conditionals, control flow. Golly. I would have called them conditional statements, but that's neither here nor there. Anyhow, I meant to say control flow. So we have our if and else statements, and then we talked briefly about switch, which gives you the option for checking a variable for multiple cases. So instead of if this, then this, and then a bunch of nested if and thens, you can do that with a switch statement instead. So that is the control flow. So that is your ifs and thens. One of the other things that we showed, I always just end up using the search bar here. So this is going to be under system alphabetically. There we go. And that is prompting the user, asking for information. If there's a user logged in, you need to get some information from them, or at least a authorization to do a thing, or you just need to pass along information to them that something is about to happen on their computer. And if you're doing that with automation, you can do that with a prompt, as opposed to remotely connecting to the machine and opening up a chat window or something like that. So if you're doing things unattended, then you can do that with a prompt. One of the other things that we are going to frequently use are actually the conditionals, which are going to give us a true/false response, so a Boolean type response. And those are the kinds of questions like, is there somebody logged into the machine? Is there a service running of a particular name? Does a particular folder exist? And so on. So with that, if that folder doesn't exist, then we'll need to do the next common task, which is creating that file or folder. So very often what we'll be doing is creating a place to download, whether it's an installer package or a place to store log files or some other temporary space. And in order to do that, we need to make sure that the folder that we are working in exists. And then if it doesn't, then we will do the step of creating that folder. And then, of course, if it is a folder that you need and it doesn't exist, maybe it's time to put an alert in that somebody has deleted a required resource, or trigger the action that reinstalls the app. And so with that, we get to logging the results of that test. So this folder doesn't exist, and so we're adding a line to the log file that says, I needed to create this folder. Maybe we should check and see if the user has deleted that accidentally, or if that application's been removed. And in order to get an alert within RMM, we can use the fail policy object. So we can get to the that branch in our logic flow of something has gone wrong and it requires intervention or some other action to happen. We can set an alert and fail that policy so that the next time you open up RMM, you will see that alert in your dashboard. And if you have it set up, you can also get your email alert or your ticket or SMS to say this machine has a problem, and then you can address it appropriately. And there we go. The next demo. There we go. Now you've gotten back into the swing of creating your policies. Let's look at actually deploying it onto your test machines. So for that, I'm going to open up my RMM dashboard. Okay, so in my dashboard here, I'm going to deploy my my new automation policy here to this machine. So I'm going to select it, and then I can go to so settings, and then to the script manager. And then you'll see here I have a whole bunch of user-defined scripts from various demos past. But what I'm going to do is add a new one to my library. And for this, let's just call it demo. And then the description is a demo policy. And if there's any sort of required parameters or anything else that you need to add for future users of that script, you would put them into the usage notes. The default timeout, unless you are doing something that maybe iterates through a bunch of files or searches for things on on the end device, on the drive, something that's going to take probably a few minutes to potentially work. The default timeout of 2 minutes should be plenty, in which case, by that point, you'll know that whether the script has finished or not. And I can choose to upload my policy either as a check or as an automated task, or both. Generally, if it's something that I find useful, I will go ahead and make it allowed to for both purposes. So a check is something that happens periodically, either throughout the day or once a day, and it will return a pass or fail. And so that's where that fail policy object comes in handy. An automated task is something that is either triggered by a schedule or by a check failing, or manually on the machine itself. So if it's a script that actually does a thing, moves files around or just reports on some information from that machine, useful the more common use for it would be as a task. But like I said, you can do any of your scripts can run as either one. So I'll usually check them both. In this case, it is going to be a script that only runs on Windows. And so let me find my AMP here. So this one is going to create a shortcut on the desktop. So uploading that AMP, save that. And now if I go and sort by name, should have my create shortcut. And if I needed to, what I can also do is go in and select a script that's already there and download it. And that will give me the AMP file that I can then open in Automation Manager. I can make changes to it, which is to say, oh, I need to be able to use this as a script check and not just as a task. Or I can upload a new version of the script if I've made changes to it. And so in that way, I can sort of keep that, that library up to date. And now, now that I have that in the script manager library, I can go in and add that check or add that as a task to this machine. So I'll just go into add a check. And I'll call this a one of our 24/7 checks, which means it happens throughout the course of the day. And any of the automation policies that you create can be used as script checks. And so here are all of my user-defined scripts. So I'll do this one. And so this is asking for those input parameters. And in this case, the demo is going back, is looking for numbers of days and numbers of errors and so on. So these parameters are the script input parameters that you generate when you are creating that script in Automation Manager. So as you add them to that machine or add to a template, then those parameters will get filled in like so. And so now my script check is awaiting synchronization to that machine. And once it synchronizes, it will start running on the usual schedule. And again, that's good for one machine, but the point of automation obviously is to save you time. So if you're applying that same thing to each machine that you manage, you'll probably want to put that into a template. So we'll go into our monitoring templates, go to manage templates here. And so let's see here. Here is my demo template. I'll double click on it to edit it. And I've already got a bunch of checks in the template here. So what I can do is add a new one. And just like before, I will add my script check to the template. And this one does not have any input parameters, but like so, now the script check is added to that template. And so any machine that I apply that template to, for instance here, go into monitoring templates and apply that template. So now that machine will have all of the checks and tasks that were part of the template that I just modified. And this is something that we cover in the RMM onboarding bootcamp, and that is setting up a machine that you have all of your checks and tasks on, doing all the stuff that you want to do. And then what you can do then is use that machine as the basis for creating a template. So if I click here and do create monitoring template, it will create a template that I can then apply to the other machines on my network. Our next demo is going to be all about variables and a little bit of math. So everyone remembers their quadratic equations, right? I'm just kidding. There's not really too much math in here, at least not difficult math. So back into Automation Manager, and I'll create another new policy. And this time we'll just call it Math is Fun. There we go. So what we will do first is search for some files. So we'll do a search. And what we can do is a file search. There we go. So we are going to search for files in our temp folder. And we're going to look for text files. And then if we wanted to look in folders that are inside of that folder, we can use recursion, but for this demo, we're just gonna leave it as such. So we talked before about input parameters and adding those to my to beginning of my script as sort of the defaults that we start the script with. And there are also what are called global variables. So parameters are things that you're asking for upfront, and those go in as sort of the first inputs into that first block of your policy. Global variables are basically just things that are well, they're global, which is to say they are available throughout your policy, and it's just a way of keeping track of a piece of information as it goes through throughout the script. So what I'll do is create a new variable, and one of the ways that you can help keep track of what is a global variable versus an input and whatnot is by giving them a naming convention. So I'm going to start with G, and then let's call this file count, and it is the count of, oh, excuse me, files that we found. In this case, we are going to do some math on it, so we need to initialize that as a number. And normally, if it's a number and it doesn't get a value, it will just default either to usually 0, or in some cases null, which is empty, but is also not 0. So typically a good idea to initialize that with a value, so that way you know at least where you're starting from. If you were working with a variable that keeps track of some text or path name or whatever, you'd want it to be a string. If you were keeping track of a date, then obviously that type. would be date. But right now we're just doing math, so we need numbers. There we go. So now my global variable is available throughout my script. So I'll go in here and do my file search, and that will result in a list or collection of files that are found by that search. And one of the things that I can do with the excuse me, one of the things that I can do with that list of objects, whether it's files or strings or numbers or whatever, is the for each object. And so I'll take that for each, drag it down here. And so as the input for the for each, I will take the output of the file search, and it gives me a list of files. And then with each of those files, I'm going to be doing something with them. So in the PowerShell backend, sort of under the hood in Automation Manager, the for each is acting on the structure, this list of files in an array. Other languages might call it a list or a set or a collection. In essence, it's just a bunch of the same type of object. So in many cases, just call it an array. So inside of this each, what we're going to do is a little bit of math. So we'll take some math objects here, there we go. And what we're going to do is add to our global variable, which is called the file count. And we're just going to add 1 to it each time this for each loop runs. So we're going to add 1 to the variable of file count or increment it, and then in order to keep up with that variable, we need to actually take that math output and assign it to, there we go, yeah, global variable assignment. So this does the math and will give us the answer, but in order to write that answer back to the variable, we need to take and assign it back to our file count variable. So we're going to take the value as the output from this math, which is the number result, and put it back into the file count. So when we are done with the loop, we should have a number in our global variable of file count that is that indicates how many objects were found in that excuse me, in that file search. There are probably easier ways to do this, but this is a good example of some very simple variable assignment and doing some simple math, and also using the output from that loop to assign something to a global variable. So one thing that you should note, these math outputs, or these math objects, have two outputs. One is the result, which, as I mentioned yesterday, the result is really just a success or failure of whether or not that object executed. So the result will be 0 if the math was actually done correctly. It didn't have any errors. You weren't trying to divide by 0 or something like that. What we need to grab for the output of this math object is the number result, which is actually the result of the actual equation. So if you end up doing something with a math object and you grab the wrong output, suddenly all of your math is going to end up with zeros. And so if your math comes out wrong because everything is zeros, that is a good place to look for it. So the results just don't make sense, then your best bet is to look in the math object. So if you give me just 1 second. Okay, so what is the point of all of this? I'm getting a number that counts the number of files, text files in a particular folder. I can get that with, the first block by itself, because it will give me the output, and I can get information on that collection. How long is that collection? The point is, if you wanted to actually do an operation on each of those files, rename them with incremental numbers, file 1 of 100, 2 of 100, and so on. Or maybe you're going to check something about the files, how large they are. These files are the same size, these files are not. How many of each different kind there are, all that kind of stuff. This way you have a counter, so to speak, that you can keep track of across all the different steps of your policy. So if you have a number, you can output at the end. That way you can monitor it and you can report on it. So if you don't specify that as an output, you'll end up at the end of the logs and all you'll get is, success or failure. So did this run? Yes or no, that sort of thing. Now, one of the other kinds of information that you're going to work with some frequency, in addition to numbers and strings of words, is dates. So you need to know when a thing happened, how old a file is, things like, is today the first day of the month, and if so, do the routine that happens on the first day of the month, that sort of thing. Dates and times are kind of, well, they're a constant cause of frustration and confusion in pretty much every programming language. What is the proper format? Is it in seconds? Is it milliseconds? Is it day and then month, or month and then day? And then, we can get started with, time zones and summertime and daylight saving time and all the rest. Luckily, Automation Manager has abstracted out most of the pain from managing dates. So go into Automation Manager again, save that, and create a new policy. Dates are fun too. There we go. So if you need to display the date of, say the current date, we can get the current date. With the get date object here, and you'll see that there are some very helpful examples of the string format that you can use to get that date output. If you need to display it, you've got all of these different formats that you can use, or you can even create your own. So if we do this, the resulting string is 4/28/2022, and then 6/14 a.m. So obviously my virtual machine is on West Coast time, which could be interesting for some of the policies that we're going to write here. But we could also change the format to just the month, day, and year. If we need to get the creation date of a file, and we can see how old that file is, or see if it is within a particular time frame. So let's get the file creation date. And the file that we want to get, let's see, is okay. So let's get and we're going to do some math with that creation date, see how old it is, for example. In this case, we're going to be doing math, but it's not enough that it is math. It is actually fancy pants arithmetic. So let's take the date arithmetic block, put it down here. So by default, parameter 1 is going to be today's date. And then for, like yesterday, we'd do something like subtract 1 day from that, and so on. And with this, we can also do the differences in dates and find out how long ago something happened. So we'll set the input here to now. So that is today's date. And then we're going to, oh, never mind. Let me do this. So instead of just doing the date arithmetic, we're actually going to use a date difference block. I apologize. Things are getting all wackadoodle here. So I can take the first date and set it to now. So that will be today's date and time. And then the second date is going to be the creation date of our file. And then we will need to figure out how many, let's see, is it hours, minutes, days? Let's get the value in hours. So for this block, I can even rename it to date difference in hours. So the result of this block will be essentially the age of this file in hours. And then what we can do then is use that information to check and see if that file is older or newer than a particular date. So normally I'd say something like, is it more than 30 days older than today? Or is it more than 24 hours old? That sort of thing. But you can use the same date difference or doing some other additional date arithmetic to determine, say, when was this machine last booted? And then if this file is newer than that reboot time. So for instance, you would get last the boot time, and then from that you can see if this happened before or after that that reboot was triggered, that sort of thing. So if you know when something happened, you can then test if something happened, before or after that event, or within a certain number of hours or days, and so on. And then for that, we would use our trusty if then or if else statement. So let's take this if here, and for example, if the date difference in hours, and that's the resulting difference, is greater than, let's say, 24 hours, then we can add something to the log that says this file was created more than 24 hours ago. Or if it is less than the time difference between the last time this machine was booted, and so on. And so with that, you can do a great deal of logical operations on new files, on old files, get the oldest files that are in a folder, or get new files that were created since the last time a user logged in, that sort of thing. And that gives you a lot of flexibility with regards to automation, because the more information you can use, the more information you can act on. Okay, so what I'll do is, let me open up my I believe this is the variables that I want. Okay, excellent. So I will start with, this should be similar to the policy that you ended up with after lab 6.1. And this time I'm going to get a list of the first 10 files in this temp folder. And then what I want to do is specify the starting conditions in an input variable. So instead of having those variables or parameters in the file search object, I want to put them into the input parameters instead, so that I can change my change the path for my searching and that sort of thing as I need to. So what I'm going to do is add in an input parameter, and as I said yesterday, I'm going to name them in such a way that if I need to, I can find them again later and know that they are, in fact, input parameters and not just outputs from another object. So in this case, I'm going to use an input parameter for the file path, and since paths are strings, I'll leave that as a string, and I'll do this with C:temp as my default value, and then I'll add in another of the file type, and again, it's going to be a string, so I'll do star.txt as my file type. And something that we haven't done before is so we've got my file count here as a global variable. But what I want to do is also add in a global variable that is the list of files. In this case, it is going to be stored as a string because there's really not any better way to store that within automation manager. If you were doing this in PowerShell, you'd probably declare it as an array or something along those lines. So, but in this case, we're going to be going back and forth between strings and arrays, which can be very handy later on. So I have my global variables that are keeping track of how many files I've found, as well as the list of files. And then I have my parameters for the path and mask. I'll actually add in one more, which is going to be the, let's call it max files. So that's max number files, and that is going to be a number, and I'll give that a value of 10. So I'm going to get a maximum of 10 files that are text files in this temp folder. So now I have my input parameters, and I can actually take this file search and replace the path and filter with my input parameters instead. And so now when I launch this, I can give it a different path each time I launch it, as opposed to those paths being built into the policy itself. So now I have my for each object. So I'm getting the list of files from that search. And then for each one, I'm going to be adding 1 to my global file count, as I did before. And so now I'm, and then once again, I'm going to be assigning that, that new number back to my global variable. So this is where we left it off last time. And what I need to do is, let's do this just for the first 10 objects. So I've got my global variable assignment. And what I want to do is if, there we go. So if my variable of file count is, let's say, less than or equal to, and then the input parameter that I've given as the max number of files that I want to operate on, then I have a variable that has that is a string that is keeping track of those files, right? So what I need to do is again do a, let's see here, is it assignment? Yeah, global variable assignment. So what I can do is take my global variable, which is my file list, right? And I'm going to take the results of the for each, which is the path result there. So what that's going to do is take the name of the file and put it into the file list. But there's a problem here. The problem is that that is going to put the name of the current file into the file list and replace the contents of the file list. So what I need to do instead is take that file list and somehow append it to, or take that file name and somehow append it to the existing file list. And so we have a whole bunch of string operations that we can do. One of them is we can truncate strings, we can replace text, we can split a string, but what we want to do here instead is the format string. So before I do that assignment, I'm going to take the format string object, and I'm going to put the current value of the file list and append the output path from that for each object. And so the resulting text is going to be something like the path of the current file that I'm working on, and then a comma, and then the current list. So what I'll be doing is adding my new path to the beginning of the list. And you can see that I'm replacing the contents of those variables with, or I'm substituting the content of those variables with these little blobs here with the curly brackets. So the output of this should go into my, okay, so the resulting formatted string should now go back into my file list variable. And so as I run this loop over my list of files, I should be building up a longer and longer string with commas in between each file name. So let's see how that looks. Running. So it's getting all of the files and adding them to string. And so when I'm done, and number 10, there we go. We can actually stop it now because it is done all 10. The result is, there we go. Okay. So the resulting string in my output parameter is, in any case, trust me, the end result is a big long string of file paths that has commas in between each one. So we have a list of files, and that is something that we can display in, say, a prompt, or send out as a list of files that need to be backed up, or what have you. The next problem that we need to solve is all of our files here. Of those files, only the first 10 are being added to the files list variable. And then for number 11 through however many, the script is still running, but it's not actually doing anything. So what we can do is, okay, so yeah, if you wanted to stop this this object running after the first 10 files, what you would do is put in, instead of just an if then, it would be an if else. So if the number less than or equal to our maximum number, if it's less than 10, then it'll do the whole format string thing. And if it's greater than 10, at that point, you would just do an exit, and then it would stop the script, or just go into a log and say this is, this is done. You can output that list of files to the log, etc. I swear there was something useful that I was doing with all of that, but maybe that gets Maybe that happens in the next lab. I've forgotten at this point. So this will give you, as an end result, if my, there we go, now it's working, a list of files that you can act on, for instance, to back up or to delete or whatever you end up needing to do. And the way you would do that is you would, again, use that that string format to build it up, and then split string to take all of these objects that are lined up in the string and split them on the comma, and then they would become objects in a list instead. Next up is using your own scripts in script checks. And I did share this just briefly a little while ago. I'll show you a little bit more in depth right now. So we're going to take a machine in our list, and we can look at the checks that are assigned to that machine. And so I have some script checks that are already on here, and they are, right now they're all failing, which is great. That's handy. And if you have an AMP or a script or whatever that you want to add to a machine, you can add it as a 24/7 check or as a daily check, either one. You just add it in here, and then put in your user-defined script, give it the parameters that your script requires, and then click finish, and you're off to the races. Additionally, you can have that script check when if this comes up and triggers that fail policy object, you can have a task happen when that check fails, and that can be either something that's already in RMM, or you can have another script run. For instance, you've got your disk cleanups, cleaning up the download folder and so on, and those will get triggered whenever your custom script check gets a failure. And so this will touch a little bit more on in the advanced topics if you are joining us for the advanced automation session tomorrow. And if you are interested in that, you need to go to the events page and register for it. Automation Manager does create these AMP files, and you can use those to deploy via RMM. But you can also deploy just plain PowerShell files that are PS1 or PS format files as scripts for your checks and tasks. So if you are proficient in PowerShell, rather than going through and learning the interface in Automation Manager, or if you find a PowerShell script that someone else has created that you are interested in using, you can do it that way as well. There's obviously millions of utilities and tools, various scripts out there on GitHub, on Microsoft's own websites, on various community forums. Some of them are things like simple one-liners, and then some of them are miles and miles long. And you could recreate those line by line in Automation Manager, but why when they're already written for you? And this is where using the run PowerShell script object comes in. Once it's integrated, now you have the ability to define your own inputs and outputs to that PowerShell script that you've downloaded or that you found or that you've written. And then you place that into the script itself. And you can actually expand on it and string your own automation manager objects together with that PowerShell script. So one of the improvements over just running a PowerShell object directly is that Automation Manager gives you a way to ask for things like passwords with an encrypted input. So you're not just saving your password in a script or anywhere in clear text, which is definitely a bad idea. So just briefly, I will show you that here. So let's say I had my list of files and I wanted to do something with them, but I already have a PowerShell script that takes a list of files and searches them for things or what have you. So then I have my run PowerShell script object, and I can just pop that down in here as the next object in the chain. PowerShell, the PowerShell scripts will actually take input parameters directly, and you can generate your own input parameters here and take the, for instance, this formatted string and send it into your PowerShell input of files as a string. And then the script itself, just copy and paste into here from VS Code or your text editor or what have you. And then that object will also generate outputs. And ideally, when you're naming these output parameters, you do something along the lines of giving it a name like PS or out or something like that. So out string, so that it doesn't end up getting confused with one of your existing global variables or one of your other output parameters for the rest of your AMP. And now once you've put that script in, that chunk of PowerShell will behave just like one of these other objects in the list, and it will run just in line with all the other objects here. Again, we'll talk more about that if you do go into the advanced automation session, the advanced automation bootcamp rather. But it is good to know that that is a possibility if you have some PowerShell experience or someone that you work with that has a library of PowerShell one-liners or utility scripts, that sort of thing. So in the time that I have left, we'll talk a little bit about best practices for when you are writing your automations. Let's say you've set up all your machines to use the same monitoring template, and they're all set to go pull down patches or updates or check a file on server at the same time each day. So you've got 100 computers and they're all going to hit the update server at the same time. So literally at the same time because they've got their clock synchronized. You might want to stagger those so the server doesn't feel like it's under attack, or else the bandwidth in the office that they're all connected to doesn't slow to a crawl at 11 a.m. each day. And there's a handy way to manage that. So you can go ahead and take a screenshot of this if you'd like. So with this little bit of PowerShell here, each machine will wait a random amount of time before doing the next step in its automation. So just remember, if your task is likely to take a long time, don't set the wait line, the wait amount too long, or you'll run out of your time limit. And the time limit for execution is actually 1 hour. So don't set your random interval to wait 58 minutes before running an update, for instance. Another example, and I'm not going to go through this line by line, but if you take a screenshot of this, again, you can have a look. The gist of this is, for example, the Sentinel-1 application actually has its own command line component to it. And then with the run script object, you can have your automation policy send queries or commands into that app and then capture the resulting output. So in a shell script, what I would say is this is very much like running a pipe. So you've got your, well, actually, there's a pipe right there. So you've got, you're running a command and sending the input into another command and then capturing the output of that command. So that is something that you can do, again, when you have a tool or an application that has its own command line interface. In this example, it's Sentinel-1 has its own Sentinel control. And you'll want to pass those input and output parameters into your script, which is great. You may be tempted to replace all the instances of a variable inside of that PowerShell script with the new input parameter. But what if you miss one? So you need to go back and make edits or changes to the original script and then drop the updates back into your automation. So the better idea is to pass your input parameter into the script as a variable, and then set that variable local to the script itself. And that way it is used inside the script locally, and then when you're done, use the opposite technique to sort of get the output out, rather than using a global variable that then gets munged around inside of your script. Set that global variable into a local variable, and that way you can take your PowerShell script and drop in a replacement or make updates to it without having to worry about finding every instance of that global variable and changing it again. It's just another sort of warning about working with variable names. And sort of in the same vein, prefixing your global variables with something like G or GV, and then do the same thing with your scripts, with your PowerShell inputs and outputs. There's no real required format or specific naming convention, so you can come up with your own, as long as you're consistent and it makes sense to anyone else who might end up using your scripts later. People that you work with or yourself later on down the line. So some examples. Yeah, so anytime you're potentially making changes to a machine with an automation policy, especially things like deleting files or double, especially when you're changing something in the Windows registry, make sure that you always test your policy on a test machine before pushing it out into production through RMM. And before you send it out to all the machines, make sure you send it to just a few machines first. So if you're going to apply that same policy to multiple machines, put the script check in that runs it into a template so that it's easy to change the template or remove it later, rather than having to go into each individual machine to make those fixes or updates later on. You take it out of the template, and then all the machines assigned that template will be affected at once. So just be wary of anything that is going to affect lots of users at the same time. Make sure that you test it thoroughly first. And then finally, more miscellaneous suggestions. As I showed a few times, renaming the objects in your script so that you can more easily identify which of those objects outputs you're referring to, especially when your automations get longer. All of the objects that say, does this folder exist, look the same unless you rename them in the interface. As you're developing more complicated policies, make sure you save it, and then save a copy whenever you make a major change or delete some pieces. Version control is a good thing. If you're using something like a Git or Subversion or what have you for doing version control, the AMP files that you're generating with Automation Manager, those can go into a Git workflow as well. They are the sort of encapsulated XML files, but you should still also be able to keep multiple versions and a history going back if you use a version control system. Avoid hiding pieces of the Automation Manager interface, especially for categories of objects, because some of the objects are in non-intuitive places. I obviously use the little search function more often than diving into the categories, and so you might hide an object or a category and not realize that it's there as an option for you to use. And finally, before you do anything, creating files or folders, renaming things, working in a directory, put in those conditional tests. Does that folder exist? Does that file exist? Is the user logged in? And so on. So now that you have a few of these policies under your belt, you should be able to troubleshoot a little bit, at least when things go wrong. So have a look at the output. And you'll see every step that the policy is taking in that sort of verbose listing of the actions taken, the variables changed, the strings are listed out, that sort of thing. The output, every object actually puts it into the log, whether you log it in the whether you actively put a log object in or not. So look for things, telltale things that are results, like I said before, where if the result is not 0, then that means an error occurred. You can add in those logging steps like I showed you before, that sort of leave yourself notes, of which path the script ended up taking, if this, then this. And so you have a little note that says it took the left-hand path and then went on from there, that sort of thing. Even little notes like I showed before, where it pops up a prompt that says, if you're seeing this, then that service is running. So, okay, so that's just a visual reminder that says, this is where the script got to at that point. And sometimes it's not your policy, but it's your environment. So particularly when you start testing, turning on and off services or changing configuration, your machine will stop looking and acting like one of your typical users' machines. So when you're trying to run your test on your machine and it's not working, maybe try on a different computer. If it works there, then you can backtrack and see what's different about yours, and then put in a test object like, does this folder exist? Or maybe a previous policy that you were testing deleted that temporary folder that you were looking for, and that's not something that you have on all of your customer machines. Do you have all the dependencies that are on your customer's machines to run the objects that you're using? For instance, some things are going to require 365 or .NET, those various PowerShell snap-ins, that sort of thing. If you're doing things in PowerShell directly, you need to make sure that the version of PowerShell that's running on your machine that you're testing with is the same as the one that's running on those customer machines, that sort of thing. And again, just like with any other scripting language, make sure that your environment is consistent with between testing and production, so that you don't get any sudden surprises when you take that script and deploy it to your users.